Okay, let's continue looking at C++ in Unreal. This is going to be part 2. And let's just start off by how we would check to make sure that our Unreal project is working with Perforce. It's a little bit different and a little more complex than just working in a blueprint-only project. So I'm going to grab our workspace. I'm going to go here. I'm going to grab the workspace I've been working on. And I'm going to refresh, and I'm always going to get latest. That's what I do. And, it's got some stuff to update. That's fine. So I'm going to go to my project, which is called FPS Template CPP, and I want to run my solution file. So not my project, but my solution file. So I'm going to open it in Explorer, and typically I don't run the solution file as is, because if someone else has made a change, sometimes the binaries aren't compatible, or even the intermediate's not compatible. So I kind of, when I start a session, get into the habit of deleting my binaries folder, and I can delete my intermediate folder. I think that's always a good idea. So I'm going to delete both. I go here, I'm going to delete, and I'm going to generate a new. So I'm going to go here, and actually I'm going to delete my solution just to make sure I generate a new one. And I'm going to hit more options, and I'm going to go to, more options on my U project and generate Visual Studio solution. Even though I'm using Rider, this will work in Rider, and it's going to generate a solution file. So you'll notice it spins up an intermediate folder, and as soon as we compile the binaries, it's going to generate the binaries folder again. And we can't run the game until we check out that binaries folder. So we're just going to let it load up here. I'm going to wait for it, and it's going to build a new solution file for us, which will be nice. So I recommend this every time you do a pull, especially if someone else is working on the project, to do that, because your binaries and intermediate may not be compatible with what you pulled in, because you're not pulling in those folders. You're just pulling in the content and other things in your project. So I got my solution. I'm going to double click it. And I'm going to hit compile, which in Rider is Control-Shift-B, but I got to wait for it to be buildable. I've got to wait for the green arrow to come up, so I'm just going to do that. I am going to wait. I'll be back shortly. Okay, so I can bring up the build area, and I can just go Control-Shift-B and build the game now that I've got that play button available for me. And that's going to make a new set of binaries. I'm going to make sure it compiles, and if it doesn't, I'll have to look at the errors. If you don't understand them, you can copy and paste them to ChatGPT, and it can give you a good idea of what the error is. It's pretty good at detecting that. So I'm just going to show you that it's generating a binaries folder here. Eventually, the whole process of creating the solution builds the intermediate folder, but now it's going to render out the, it's going to compile the project and run and compile binaries for us. So it started with RC2, and I'll be back when it's done compiling. Okay, it's done compiling now. So now we can check, and I can show you that the binaries folder, if I go back here, it's created a new fresh set of binaries. So we got a new DLL and all the files we need. So the next thing I'm going to do is I'm going to check that binary folder out. I can't compile over them now without checking that out. So you'll get an error if you try and build. So I've got to go to my project, which is CPP template here in P4V. I'm going to hit refresh, and I'm going to grab that binaries folder that I recreated here, and I'm just going to check the whole folder out. All right. So now that I've checked those binaries out, I can start working on my project. So I can hit play button here, and it's going to launch Unreal. I'll be back with you as soon as it loads. Okay, the game's up and running now. So you remember, we just basically did the first person controls. So I can go into the game, I can run around, I can speed up, and I can jump. So I got the basic functionality plugged in C++. Now let's add the ducking like we did in the blueprints. Let's walk through the blueprints code so we can just refresh your memory on what we did. So I'm going to go back to the project. And I'm going to grab the blueprint that we did. So this is in my class. And it's my project. And it's FPS level design. And this is where I did the ducking. So let's take a look at how we did it in a blueprint. Now we're going to convert that to C++. It's definitely a lot trickier and more verbose, but also in some ways more powerful. We have more flexibility in C++ to do what we want. We're not limited by what the blueprints can and can't do. So if I remind you, if I go here, hit play, excuse me, I can just hit control and I can duck and I come back up. And when I duck, I raycast to make sure that there's room on top. If there's not room, I don't get up. And then as soon as I have room, I get back up. Oop, I'm in the damage volume. We're not going to do damage volume here. We're just going to do the ducking. So let me show you that code again, just to refresh your memory. So that was on the player. So the BPFPS pawn. And on that, we had, we added the ability to duck. And in that ducking, we basically had we called duck when we started it, and we called duck when we completed it, and that calls it with the isDucking set to true or false, and then we set isDucking to true when we call it. And this just calls this custom function down here that if ducking is true, that means we're in the act of ducking. If it's false, we're in the act of rising. We were ducked and we're trying to get up. So if it's true, we come here. We set a new duck speed so that we don't walk as fast. We have a max run speed. So we make sure that we're actually running at the regular speed and not sprinting. And then we start the ducking animation, which is this timeline that goes from 1 to 0.5. So we multiply this value by your height, the half height of your collision volume in your pawn. So you essentially shrink the character. Let's go back to the event graph. So it takes your capsule component, it multiplies that by your standing half height, which is 88 centimeters. So when it finally gets to point, it's going to go 1.9. So this number will go from 88 to 44. And the end of it, it'll be 44. And when it's complete, if the ducking scalar is greater than 1, that means if you're going back up, because we go forward when we duck, and then when we are getting back up here, we check to see if there's room to rise, and then we go in reverse. So when we go in reverse, we come back and we set isDucking to false. So you're no longer ducking when you've finally finished getting out, getting up. So that's what this code does there. And then when we're checking if there's room to rise, that's where we create the multi-sphere trace and pass that to that function. So we're going to do all of this in C++. So let's quit this project. Let's get back to our C++ game. And let's start doing that step by step. So first step for us is going to be, I'm just going to move this over a little bit so I can read my notes. So the first step is to assign our crouching. So we need an input action. So we go back to our pawn. We are going to go to our input actions, and we need to add one for crouching. So we're going to go here. We're going to right click, add an input action, and we're going to call it IA crouch. And that's what we're going to do for crouching. And we're going to leave it at the base controls because it is a Boolean. So we don't need to adjust this. It's not on a joystick, so Boolean is fine. That'll be good. Then we're going to go to our IMC default controller, our input controller, and we're going to add crouching. And we'll do that on the control, left and right control key. So we're going to add a new mapping. Oh, I hate how it does that. We add a new mapping, and that new mapping will be IA crouch. and it does it again. And then in IA crouch, we're going to add 2 buttons. So first is going to be left control, and then the next one keeps reopening these things. I can't believe they can't fix that. Right control. All right, there we go. So left control, right control fired off. Nothing else we need to do, nothing fancy. So now we need to add that crouching action to the player blueprint. Actually, we're going to do it, of course, to the C++. So we're going to add it to the header file. So we're going to go back to our C++ code, go back to Rider, and we're going to make sure we open up we had everything in private and public. So our public is our header, and private is a CPP file. So we always do our definitions in the header. Sorry, we always do our declarations in the header and our definitions in the C++ file. So we need to add a declaration here because we had our various actions. We need to add another action. So I'm just going to copy and paste this. And now we are going to add the crouch action. And then we're going to need to create 2 new functions that we bind to when that crouch action is called. And the first, if you remember, we had a crouch start and crouch end. So crouch start is where you begin to crouch, and crouch end is where you end to crouch. So we're going to call it void crouch start. And we need to always pass it the input value. And then void crouch end. And the same thing, pass it that input value. And then we need to do our definitions for them. So we need to bind our actions. So we need to basically take that crouch event and on the button start, call crouch start. And then when we release the button, call crouch end. So that's what we're going to do. So we are going to go in and we're going to create the definition. So I can just go here and do a shortcut, create a definition. And then I can go back to my .h. Here, let me close my other windows because I'm just working in Pond for now. Don't need these others open. Distracting me. In here, I'm going to create the definition for this, and it's just going to rough in a definition in my CPP. So a definition for crouch start and crouch end. Now I got to bind the action, right? So I've got to go here. And we've got to bind crouch start and crouch end on the started and completed button. So I can just grab the last 2, duplicate them, and call this crouch start. And this one crouch end. Because those are the 2 functions we're calling. And this is not on sprint action. This is on crouch action. So on crouch action, when the started event is triggered, it will run this. And when the end action, when the button is released, it will run crouch end. So let's just add some print statements just to make sure it's working. So I'm going to go UE log. I think it's temp. Is it temporary? I can't remember what the UE log. Do we have a UE log that we used earlier? Yes, log temp. That's what it is. Okay, so UE log temp. And we're going to do, let's do a, it doesn't really matter. Yeah, let's do a warning. And it's going to be text, and it's like crouch begins. And then here we're going to do the same thing and go crouch ends. So let's just always test our code first, make sure it works. So now I can hit compile. I want to make sure it compiles correctly, and then I should be able to test it in game. And when I press control, it should start. When I release control, it should end. Print that end message. It'll say crouch ends, yes. So it's compiling. I'll get back when it's finished. Okay, it's succeeded. So we can go in now, and I can press play. And then when I, let me change the output log and dock it in the layout so I can see it. So I'm going to grab that input log and I'm going to clear it. I'm going to hit play. I'm going to press crouch and let go crouch. And I don't see anything. Okay, let's make sure that I actually did bind everything correctly. So I have, oh, I know what I need to do. I don't actually know anything about that button right now. So if I go to my player, go to my pawn, we had bound everything except I did not bind the crouch action. So I added it to the C++, but I forgot to go in the blueprint and actually assign it, because don't forget, I created the input action in a blueprint. So the CPP doesn't know anything about blueprint. So I've got to actually bind it here. So now that I've done that, it has a better chance of working. Well, it has a chance of working because it didn't before. So I'm going to go back, hit play, press crouch, see begins and ends. There we go. So my crouch begin and end message plays. So my crouch button is working exactly how I want it to. So what I want to do now is I need to add another item in the element. So in our other project, we had that timeline. There is not a timeline per se, but I need to access that float curve we created where it went from 1 to 0.5 over a second. So what we're going to do is we're going to create just that graphing part. So we go to our, let's go to our content drawer and let's create it. So we'll create it in the blueprints folder. It's going to be part of our pawn. So we'll create it here, and essentially it's a miscellaneous, and it is a curve. So I believe it is just adding a float curve. So it's a curve, and then it's going to say what type, and I want curve float because it is a floating point curve. And we're going to select that, and I'm going to call it cur underscore, and this is going to be ducking lerp. So it's our ducking. It's not really a lerp because it's not linear, but that's fine. I'll call it that for now. And I'm going to create two keys like we did in the last project. So we're going to double click. We are going to add a key, First one is going to be at 0 on the timeline, and it's going to be set to 1. And the second one is going to be set to 1 on the timeline, and it's going to be set to 0.5. And then I'm going to make it, I'm going to break this and make them curves. So I'm going to break them and break it and make that a curve. So it's an ease in and then it ease out. So it doesn't just go straight in a lerp, in a linear interpolation. It nicely ramps up and ramps down at the end of the animation, makes it look better. So that's going to be our ducking animation, and this is this is not the whole timeline, but it's part of it. It's part of it. So I've got to go back to the code now, and I've got to continue to work on it. So I'm going to go back to the project. I'm going to go to my header file, and I'm going to add a link to that curve. So this is basically a float curve. So I've got to go float. So I've got to go type is UFloat curve, I believe it's going to be called. Or is it FFloat curve? FFloat curve. Yep, it's an FFloat curve, and we're going to call this crouching curve. And it's a pointer. So it's not the actual curve data, it's a pointer to that in memory because that can be fairly large. So I'm creating my pointer, and this is going to be a U property that is read-writable. So the user can assign that curve we just created to this. So this is going to be an appropriate type. FFloat curve cannot be exposed as a pointer of this type. It cannot be a pointer, really? FFloat curve? Okay. All right, maybe it can't be a pointer. Maybe I'm wrong about that. I might have to add the definition for it, but it's not asking me for it. So let's see if it complains when it compiles. It might basically say, hey, you've not given me the definition for float curve. Not sure if it comes in with the, oh no, it's succeeded. So if I go to my player pawn, I should probably see a float curve pop up. And what did I call it? I called it, so it's under enhanced input, which it shouldn't be. It should be under movement. Let's put it under movement. Let's change that. Let's recompile, go back to the game. And it succeeded. So I'm going to grab my player now. And in movement, crouching curve, and I have nothing to assign. Okay, that's interesting. So it's not allowing me to assign it. Let's just check my settings again. So it's in blueprint read write. It's a U property. Yep, edit anywhere. Okay, float curve. All right, I'm going to have to look at my other source code and see what I did differently with it. So I'm just going to go grab my project, and I can't remember from memory what I did. So let me go to my class notes. No, that's not it. Go here, and it's FPSCPP. I'll grab this solution file here, and I'll open a new window. This here is just as a reference, and it's my float curve. So I had a float curve, U float curve as float curve. So why can't I? Maybe I didn't allow private access. Maybe my U property wasn't correct. So let me just go here. Let me just copy my property, go back to here. And it was a U float curve, by the way, not an F float curve, U float curve. And it's undefined. Sometimes Router does find it. And I can add the, but I can also forward declare it. So I'm just going to go here and go, because it's gonna find it. It's linked to it. It's part of their core libraries. So if it's part of Unreal, you can forward declare. I should be able to forward declare, and now I can make it a type, a pointer, and it says unable to find class delegate struct with UFloat curve. Okay, let's just see. That should have forward declared it. Let's just try compiling it. Sometimes it sees it later. Maybe I misspelled it. But I have a feeling I've done something wrong here. So I made it visible anywhere so that you can see it. You don't need to access it in a blueprint. I'm going to do all our functionality in C++, so I'm not worried about that. I'm just compiling it and seeing what I need to do here. So, and it's taking its sweet darn time here compiling. Not sure why the forward declaration. Let me just take a look at my previous project. And did I forward declare the curve? Yeah, class U curve float. I certainly did. I did not put it in the header. I did not include the header. So, feeling this is going to fail. Did it just say it completed? Nope, it's still compiling changes. Boy, it's just slow. Normally it compiles very quickly. I'm not sure why it's taking its sweet time right now, but, and if I don't have this window up, I don't see that message saying it's still trying to compile. But I'm not exactly sure why I'm getting that error. Float curve. U float curve. Oh, U curve float. Oh, well, that's, for starters, that's my big problem. I just spelt it wrong. I'm dyslexic, so that's not right. Let's go back here, and it's U curve float, which would help to get the right nomenclature. Wow, come on, Mark. Whoa, my computer is slow. Curve float. And I can't spell again. Curve float. And up here, do curve float. And curve float. And this time it's not giving me a red underline, so I'm more confident that it will compile, but hopefully it won't take as long as it did last time. So it's compiling. And it's linked it. Okay. So now I can go back to the game. I can go back to the game. And I can grab my player pawn. And under movement, I do not have this accessible. Okay, again, not working. That's all right. We'll figure it out. So I go here, and I still don't see it under movement. Okay, let's go back in and see what's wrong. So I've got visible anywhere. Oh, it should be edit anywhere. Well, actually, that should work. So I'm allowing access. It's set to crouching. Oh, let's set it to movement. Let's not set it to crouching. Let's put it in the same category. It was probably there. I just didn't see it. Let's go back to the game. And it's loaded up. So let's go to FPS pawn. And there we go. There's our selection for the curve. It's not allowing me to select it because I've not allowed editing for some reason. Visible anywhere. Let's make it edit anywhere and compile. So not only has to be visible, but we have to edit the crouching curve because I got to assign it. So if you get read only, that's what I did wrong. I set as a wrong type. So here I can go in and I can select my, I think I called it a CU underscore, what did I call it? CU underscore ducking, cur ducking. Nope. Cur ducking. There we go. There was my curve that I made that went from 0 to 0.5. I don't think there's a length in the actual curve setting like there was. I think it is just basically I set my two keys and the length is just eternal. So I think that's fine. I think we'll just read it for a second and go back. So I'm just going to go to my notes. So that is our curve in the player pawn. So I need to add a U function. And that U function is going to be called, I'm going to add a U function to all controller bound functions. Oh, right. Yeah, I forgot to do that last time. So let me just show you. If I go back here, it's a good idea. Certainly for U properties, I believe you want that for garbage collection. So you always, even if you want to hide it, it's always good to just do U property, even though that's not a U property. Same thing with U functions. So I'm going to give it no particular. I'm not going to make it public or callable in a blueprint. I'm just going to make it a U function, just so that the compiler knows what it is. The Unreal knows what it is. It's not for C++, certainly not needed. This is a macro that only matters to Unreal, but for its header tool and for its build tools, it's probably best to do this. So I'm just making sure that I'm telling it, hey, this is a function. And it's an Unreal function. So, all right, so I've added the function. So now let's add a timeline. So again, timeline is something that exists in Blueprint, but does not exist in C++. So I've got to add the timeline component because it is actually a component. Here, let me see if I can load up the old game. I'll show you what I mean. If I load up the non-CPP project, so the first person level design, and I load that up, you'll see that the timeline component, the timeline actually goes on the component side, and it's in a special place, not the same spot in the top left corner where our static meshes and other components are, but another component area. So if I load it up, you will see that, let's go back to the blueprint version that we had earlier. And I'm going to go to the blueprint and in the player pawn. And here, if I go to my timeline is ducking. If I go to the right and I go to components, I can see ducking. So I've got a ducking component here. So I know that's a component. So essentially, I'm going to add a component, and their components are named pretty consistently. So we're going to basically say, again, edit anywhere. And it's going to be, instead of a U-curve float, it's going to be a timeline component. Timeline component. Is it a U timeline component? U timeline component. And we're going to call this, crouching timeline. Crouching timeline. I'm going to add the forward declaration up here. So class U, and it's a timeline component. Timeline component. Okay. Let me just compile that, make sure that works. So we're going to construct it in C++. Okay, so we're going to go here, and then in our constructor, where's our constructor? To the top. We constructed a camera component. We're going to do the same thing with the timeline. Let me just grab my sample code here, and I'm going to put it up in the monitor next to me so I can see it. Give me a second here, sort of get the right scale. It's all screwed up. Just a second, I'm going to be back in a few seconds. I just need to get this to scale properly. Nope, it's in the wrong screen. Okay. I'm just going to go to my notes and go timeline component. Okay. All right. Okay. So in our constructor, after we construct the camera and make all those settings, we are going to also do our crouch timeline, which I called crouching timeline. Now I'm going to have to include the header for this uTimeline component because that was not included earlier. So that header is in, let me just go, that is in components timeline component. So it's in include. Sometimes it'll fill it in for you, but other times you just have to, you can look it up on Google on their website and they will tell you what the where it's located. But I just know it's in the components because that's where most components are. And then I am creating it. I don't need to bind it like I did to the camera because it's not attached. It's not an object in the game. It's not attached to the root. So I don't have to do this. I don't have to set up the attachment to the root component because it's not there. It's a component sort of all on its own that doesn't tie in. It's not an object in the scene. So that's that. And I've also got to create another function here that I'm going to need to use. And that is an rInterp function that in C++ I need to access that timeline. So I'm just going to go back here, and that was a, let me just see, where was that? There it is. Okay, so I need to go back here, and I'm going to create another U function. And it's going to be called, sorry, I'm going to go back to my .h. I'm not going to make this one a U function for now. It's on timeline float, F on timeline float, yeah, F on timeline float, and it's interp function, and we're going to give it an empty definition. And that F on timeline float, I'm going to forward declare. That's F on timeline float. And that should compile. No, it's not. Something's not right. It says it's incomplete. Okay. F on timeline float. It's not happy for some reason. Let me go to my notes again and see. See where I got that. There it is. So F on timeline float, interp function. Timeline float. Interp function, that looks right. Did I just misspell it? Whoa, that's not what I wanted to do. Just a second. Copy and paste it. See if I've got a slight spelling error. Or did I not declare my for? Did I not make my for declaration proper? Or maybe I have to actually, maybe I do have to include it in the, nope. U timeline on timeline flow. Oh, right. I don't call that. I basically, yeah, timeline component, U curve float. I actually don't do this. I might actually have to include the timeline component. Maybe that's what I did differently. So the timeline component is not in the CPP file. I do need it in the header because I am actually generating that function. And whoops, I can't do it before generated. You always get an error. All your headers in the header, all the includes in the header file need to be before this generated. And let's see if that clears up the compile error with our interp function. Yep, that is now no longer complaining to me. That's good. Okay. So we need to add a half player height to the game. So that was the 88 going down to 44 centimeters. So we're going to add another U property. So we're going to go U property, and it's got to do with movement. So yeah, I'm going to just copy and paste this. Nope. Copy and paste this. And this is going to be called movement. We're going to allow editing anywhere because it is, you could change it if you wanted, and it's going to be called, this is going to be called player half height, I think. Player half height, and it's a float. Floating point number. U float. Sorry. F float. Is it F float? Yeah. No? Oh no, it's just a float. What am I doing? It's not, it doesn't have to be a Unreal type in this case. So it's player half height that is a float. And then in my CPP in the constructor, I'm going to set it to 88 centimeters. So sets height to default 88 centimeters. And it's player half height equals 88 dot, and I have to declare it as float type, otherwise it defaults to float double if I don't put the F there. And I don't want to be casting between types. That's not a good idea. At some point in class, you can ask me about that, and I can explain what's going on. Okay, now I got to bind that function in the begin play. So I've got to bind that. I got to bind that function so that we can get that movement component and actually call it. So let me just check what I did here. Oops. Let's just make this smaller so I can see more. There we go. I can see what I did. So essentially in our pawn CPP, we're going to go to begin play. And there we get our movement component. And then now we've got to set up our, we got to bind that component and we've got to add that float curve to it. So we're going to go interp function dot bind u function. So we're going to bind this object to fname, and it's going to be called crouch timeline exec. Oops, lowercase. So that binds the u function crouch timeline exec. Is that what we called it? Crouch timeline exec? Let's just go back. Did I create a, maybe I have to create a function too. Crouch timeline exec. Yeah, we had a u timeline component. I don't think I've created that yet. We've got to create a timeline component as well. Or did I? U timeline component. U timeline component. So yeah, I called it crouching timeline. Okay. It's going to go here and go crouching timeline exec. So we're going to bind that function and we got to execute it. So it has to be spelled very specifically for it to work. So hopefully that will actually work. And then we're going to go to crouching timeline. And then we're going to add the interp float. So that float curve that we had. Interp function. Okay, it's not cast float curve. It's the floating curve we added, and we called it a crouching curve. So that's what we called it. So it's crouching curve. So we're adding that crouching curve to it. We got to set looping to false, otherwise it'll just keep going up and down. So yeah, I believe it defaults. It might default to false by accident, by default, but let's just make sure that it's false anyhow, just in case. So we're going to go set looping to false. I'm going to set its length because if you remember, it defaults to 5 seconds. So we had to change it to 1 second. So we're going to do that right here by going set timeline length to 1.f. Again, it's a floating point number. Then we're going to create a timeline event. Finished function. F on capital O. F on timeline event. Okay, and I think I have to add that. So F on timeline event is up here. So do I have the timeline component in my, no, I do not. So I'm going to have to add the timeline component. So this is going to be include components timeline, oh, can't spell, timeline component. Let's see if that helps the compiling. Nope, it does not help the on-time event. F on-time event. Is that what it's called? Let's just double check that. It's F on-time line event. Sorry. Oh, F on timeline event. There we go. Woo. And then we're going to go finished function. So this basically, this is the starting pin, and this other one will be the ending pin. So we're going to create a, so that was crouching timeline here. So did we create an I wonder if I created actually an exec one. Maybe I did do a crouching timeline exec here. Yes, I did. So I'm going to need that. That was for the first, the first bind was to a U function. It was called crouching timeline exec, and we're passing it a parameter of value, of a float parameter, and we have another U function. So this is when you start to crouch, and the other one's going to be when you end. Is going to be called void crunch timeline finished. I don't need to pass it anything. It's going to be empty parameter list. And it's a U function, not a function. And crunching timeline wants a definition. I'm sure it needs must have a return type. Of course it does. It's void. Both of them are void. They're not returning anything. Yep. And then I'm going to define it. So generate a definition and then go back here. So I've got my timeline exec, my timeline finished, and that's what's binding in my begin play up here. Where's begin play? Begin play, begin play. Yeah, so timeline exec, and then I am going to bind the finished. So we're going to go, so I have to create that finished function and then go finished function, and we got to bind it to another function here, bind to function this, fname crunching timeline finished. Okay. And it's bind U function, I think, not function. Bind U function. This, oh, and name is lowercase. Name. So crouching timeline exact, crouching timeline finished. I got to make sure those are spelt right. I'm going to copy and paste them. Just because, oh, I called it slightly different. I call this crunch. Okay, well, let's call this crouching, Mark. Don't be silly. Crouching. Okay, crouching timeline finish. Let's go back to our CPP. And I'm going to call it crouching timeline finished. Okay. Back to our begin play. And then basically we're going to go crouching timeline, and set timeline finished function to finished function. Can't spell. Finished function. All right. So this binds that function to that finishing pin. Okay, so what do I need to do next? So I've so basically I don't want to set the capsule height in crouch start and crouch end. So let's go back to our crouch start and crouch end. Oh, I didn't do anything in our crouch start and crouch end, so I haven't done anything yet here, so that's fine. So in our crouch start and crouch end, let's go to that. Let's just go to my notes. There we go. So essentially, my crouch start, first thing I want to do is make sure the player is not at the sprinting speed. So basically, if player is sprinting, slow down to run. So character movement component, and we're going to set the max walk speed to max run speed. That's what we called the variable. We had max sprint speed, max run speed. So max run speed is what we want to do. And that's on the crouch begin. And then we are going to go crunching timeline. Is it not called crunching timeline? What do we call it? We did crouching timeline. Why do we call it crunching? Man, I am spaced today. All right, let's go back here, call it crouching timeline, and we're going to start it. So basically start the event just like we did in the game, in the blueprint. So we hit play, and that starts that timeline. And then we're going to go B is crouching. We're going to have a Boolean that sees that the player is crouching. We're going to need this later on. So we're going to set that to true, and then we're going to assign that Boolean. So essentially, we're going to make a U property. It's going to be hidden, so we're not going to show it to anyone. B is crouching. Now you could set it to display only, and then you can't change it in the blueprint, but you could see it if you want to debug it in the game. But I think I'm going to be okay. I think I can just keep this. And this is going to be type Boolean. And it's going to be called B is crouching true. Okay. Now remember in Unreal, they want the Booleans to have the lowercase b. And if you in the game, it's going to drop it and it's going to show is crouching. But that's how Unreal likes us to call it Booleans. Not that it would hurt if you didn't do that. So now my B crouching should be true there. And then on my, that's on my actual crouch start. So it plays that timeline. And then on the crouch end, we'll figure that out because that's a little more complicated. So on the crouch start, we basically call, we play the timeline, and that will call the crouch timeline exec. So that's going to call crouch timeline exec, where, oh, I don't want to put this here. This was not meant to be, this was not meant to be here. This was meant to be in, this was meant to be in, where was that? That was in crouch start. Sorry, this was meant to be in crouch start. I put it in the wrong place. Whoops. This is supposed to be, sorry, Control C, crouch start. There we go. So we are going to, we'll get rid of that printing after. That's in crouch start. And then on the exec, we're actually going to, this is when the timeline runs. That runs the timeline. And then when the timeline runs, we are going to crouch line exec. Where is that? Where is crouch line exec? There it is. So on crouch line exec, we are going to get the capsule component and change the height. So get capsule component, and then set capsule half height. And we are going to set that to value player half height. So we're taking the value, so the float that it's passing us from the, so in our timeline, we're sending the value that comes from that graph, and we are multiplying that by the player height. So it's going to 1 times 88 will be 88, and then 0.5 at the end times 88 will be 44. So it's going to go from 88 to 44 with a nice smooth animation. And we're going to scale the speed as well. So we're going to do exactly the same thing with the character movement component. I'm just saving myself some time. We could have a separate value, but I'm just going to use the exact same curve. We could have a separate curve for the player speed, but I'm saying half speed's fine. So max walk speed equals max run speed times value. So it's going to slow the player down as he crouches. Player will slow down. Let's test this out. Let's compile, make sure it actually compiles. Why do I think it's not going to? We'll find out. Okay, so we go to the game and it compiled all right. And I go and I'm going to play the game. I'm going to play the game. I'm going to go in here. I'm going to press the crouch button. And it says crouch begin, but nothing happens. Okay, so something's not quite right. That's fine. Let's go in and check out what is wrong. The logic. So it is calling crouch begin. So I know that. So it's calling that function, and that is on crouch start. Let's just make sure it's calling the next function. So crouch start is here. I'm going to move this here. And so it calls maximum walk speed. Let me just check that crouch start. And then the crouch timeline play should trigger this exec if I've done everything right. So let's just go and call this timeline starts playing. Timeline starts to play. Let's just see if I'm even calling it. I don't think I am. I think this would actually be setting that height. I remember setting it in the constructor to 88. And if it was 0, my camera would just drop to the ground. So I think that should be working. So let's go back to the game. Let's hit play. And nope, just crouch ends. So it's not printing that message. So it's not causing the timeline. Oh, I don't know. Oh no, I did assign the timeline. And I think I assigned the float curve to it. So it should have passed. It should have passed that. So let's just double check everything again. Let's just go back. And let's start with our timeline. So I should have created a valid timeline in the constructor. So here, should have created a timeline component, a crouching timeline, create default subobject, and then in begin play, I should have bound it. Let's just make sure these are spelt right. Crouching timeline exec. Crouching timeline exec. Oh my gosh. Let me just go here and make sure that that's spelt right. And then crouching timeline finished. So add interp, set looping, set timeline. And if it didn't do this, I would assume, like if my crouching timeline should be working. Otherwise, I would get some errors here. I'd get an error, and I think I would get an error on the binding even. Let me just see if that was it. It was just a spelling mistake, which wouldn't surprise me. I'm feeling it's something else. Go in here, go, start, and crouch ends. Okay, so that's not it. So crouch timeline exec calls crouch timeline exec, which is crouch timeline exec. When I play the timeline. So I know I'm playing the timeline because I am on crouch start, calling the timeline to play. it should be calling crouching timeline exec. You just print the message for started. I can check to see. I can put another conditional check to see if it actually does play. Because, yeah, crouching timeline started, but it's not actually calling it. So it's not either not binding it, either not playing it. I'm not exactly sure which is which. This is calling a float a crouching timeline exec. Okay, that did something. I think I just didn't have. There we go. I go down. So it's working, and notice it's ticking when it's the animation's playing, and then it ends and it stops ticking. So it's very efficient, right? So it only ticks when it has to, and then stops ticking. So it goes down and then stops. All right, perfect. It was working all along. Sometimes you have binding problems and it doesn't bind properly, but I didn't actually change any code here, and it just worked. All I did was added crouch end to a print, and it was just restarted the game that kicked it back in. That's happened to me in the past. So that's good. I've got everything running then. So last thing I need to do is get up. So one of the things we have to do is make sure, we have a problem here. Let me just put down a cube. So I'm going to put down a cube here, and I'm going to put it next to my player start. Let's just go here, burp. Let's make it bigger. And let's see if I can crouch under that. Oh, it's a bit low. Let's raise it a little bit. Burp. There we go. And I'm going to walk up to it. I'm going to press crouch. Oops. Nope, still not high enough. So let's go. Let's raise it a little bit more. I want to make sure it's high enough that I can't walk through it without crouching. So I want to hit it. Yeah, I want to hit it. But if I crouch, I want to go underneath. That's perfect. Now the problem is we have no standing up code. So let's put the standing up in. So what we're going to do is we are going to go up. So in our crouching at the end, we have got to basically play that timeline backwards. So let me just see where I get that. Crouch timeline end is here. My end, right? Crouch end. Okay. So my crouch timeline end, I'm going to reverse the timeline. So I'm going to go here, and I go crouch timeline end. So instead of doing that, I'm going to comment out my logs. Got all of you working. So on my crouch timeline finished is something different. Let's leave that one for when it's finished. But when the timeline on my crouch end, I want to get back up. So basically, I'm going to call crouch timeline reverse. And it's called crouching timeline, I called it. So instead of starting, I'm reversing it, and my player should go up. So let's try that. Let's go in here. Let's go back to the game. And now when I press release, it goes back up. Now there's a problem. If I'm under the platform and I go back up, I get stuck and I can no longer move. So we have to check. We have to cast a shape that's the same as the player, make sure there's headroom for the player to get up there. So there's a few things. One is it's going to be recursive because if it does hit its head, it's going to have to wait. And remember, it's not ticking. So we're going to have to call ourselves back, and I can't call crouch end. So we're going to have to create another function that's going to take that place where we can recursively call ourselves. So crouch end is going to call a crouch end check. So we're going to create another function. So a U function, and it's going to be called void, and it's going to be called crouch and check. So it's going to check to make sure that we have room to move. So we're going to generate that. And now I'm going to move the reverse to there. And we are going to go crouch and check. We're just going to call it. So it's basically doing the same thing, but I can now call crouch and check at the end of it if we can't get up. So we're going to use a C++ version of that collision query. So we're going to go, so we are going to go here first, and we're going to start with using a sphere the size of a player collider to check to see if there's room to rise. So use sphere trace, see if there is room to rise. So we're going to create an F vector. We're going to get an F vector start, and that's going to be the character location in the world. So get actor location. That'll give us an XYZ of the character. It's an F vector. And then we're going to go F vector end, and that's going to be our start location plus F vector. So we're going to add on, we're going to go up on the z-axis. So 0f on the x, 0.f on the y, and it's the player half height. We're going to go up half a height. So because it's going to start the spherical check in the center, and then we're going to go up half a height. And that's essentially the player height. So that should be fine. So that's, why is my F vector? Oh, I've spelled vector. All right. And this is the size of the player is 34F. So if I go to the player, want to create a sphere that is the same as the player's, whoa, where did that get to? I want this. Okay. So the player capsule component, I want that 34 there, that capsule radius. Because I'm going to create a capsule and then go up by 88 centimeters to get to the top of the player height. So that is going to be back over here. And it's float sphere radius equals 34F. And if I declare the float in the, rather than declaring it in the header, it's going to free up the memory when it goes out of scope. So it's not going to stay around. I don't need to keep this value. It's staying the same. I can make a constant, I guess, but in this case, I'm just going to create it. And as soon as this function goes out of scope, that memory will be freed up for something else. Then we got to get some collision query parameters. And I might have to add those F collision query parameters to the header. Collision query parameters. Do I have something about collisions up here? No, I do not. Okay, maybe that's okay. Maybe I don't. Or maybe I added them to the header. We'll see. So query params. And if you remember in our blueprint, we ignored the actor. So we're going to go query params and go ignore add ignored actor. So we're not querying ourselves. I don't want to collide with myself. I always collide with myself. That's always true. So in this game, that's not going to work. And then we're going to go B trace is complex. So we're going to check the full mesh, not just the collision mesh. And we could set that to false if we want, but I think it's better for this case. And then I'm going to create a T-array of F hit results. So when we do hit something, we can get information about it, and we'll call that out hits. So now we've got to sweep by channel. So we're going to do a sweep. So we're going to go, and it's going to be bool b hit equals get world. So we're getting the level, and then we're calling sweep multi by channel, and we're storing, so sweep multi by channel, let me spell that correctly, Mark. And then we're storing it in, first thing it wants is the hits, so the out hits. That T-array I created. Then it's going to want the starting point and the ending point, so we called that start and end cleverly. And then next it's going to want the rotation, so the sphere is not rotating, so we're going to go F quaternion identity. So no rotation for the sphere, essentially. And then after the rotation, it wants a collision shape, and it is a sphere. It's not a line. It's not a box. So F collision shape make sphere, sphere radius. And then finally, it wants the query params that we created above. Query params. Whoops, did I not spell that right? So F, I've got my collision shape. Make sphere, sphere radius. Did I create a sphere radius? Oh, yeah, I did create a sphere radius right here. It should be there. F collision shape. Query params. No, that's there. Got that. Oh, I forgot something. After the identity, sorry, I've got to use the visibility channel. We're not going to describe what this is, but it's basically querying anything that's visible. That's what I forgot. Okay. So now, if it's not hit, let's just check, see if it works. So we're going to go if B is hit. And we're going to print the message saying there is a problem. I'm going to just delay the reversing. We're going to do that when it's not hit, essentially. So actually, yeah, we can actually put that. We can put that on the else condition. So when it's not hit, we can reverse. But we're going to print messages anyhow, just to make sure everything's working. So I'm going to go into UE log, and on the hit, we're going to go player cannot rise. Player cannot rise. And then on the else, we're going to go player can rise. There's room for them to rise, essentially. And then if they can't rise, we're going to call ourselves, but next tick. So we're going to go, so basically if we are hit, we're going to go get world, which gets the level. And we're going to get timer manager, which gets our timer, and set timer for next tick, which calls the next tick, very much like the blueprint we had. And then we're going to basically call at FPS pawn And we're going to call ourselves crouch and check. That's what we called it. AFPS pod, crouch and check. So basically we're going to just keep checking until we find it, which will cause that to effectively tick because it's going to grab the next frame. So let's just see what we get. All right, let's go to the game. Let's hit run. And when I go down, we crouch. And, oh, I rose there. Oh, I'm not seeing my messages because I've not scrolled down. Let's actually look at our messages. Let's go here. Let's crouch. Cannot rise. And then I can rise. And I rise. And I run into it. Perfect. I've got everything working exactly the way I want. So I crouch. Oh, my sprint button is sprinting. So there's a few more things I have to do to clean up. So I've limited it, but now I want to set my max, I want to scale my speed. I've done that. So basically I want to stop them from sprinting. So I've got to go to my sprint. So I'm going to get rid of a lot of my print statements that I don't need anymore because it's working the way I want. So I'm going to go back here and I'm going to get rid of that log and that log. And now when I basically have sprint, I've set B as crouching to true. And remember I had the end. So when timeline's finished, rather than typing timeline finish, I'm going to go B as if. So when timeline is finished, I've got to make sure that the player is, the timeline's finished when he gets back up, not when he gets down. So I'm going to check to make sure that it's actually at 88 centimeters. So if get capsule component, get scaled capsule height is equal to player half height, which is 88, then I can set B is crouching to false. He's no longer crouching, he's risen. And then on my sprinting, where I go sprint, I can go if B is crouching false, then sprint. And I can put the same check on stopping to sprint. And this will stop my player from sprinting while crouching. Go back to the game. I hit play. And now, whoops, when I go, I crouch. So when I'm crouching and I press the sprint button, it no longer sprints. Okay, I can get rid of that timeline started message. Let me just search for UE log. Timeline started. All my logs should be now. And I think I've done pretty much everything I need to do. The only thing left to do is to really test whether that boundary works. So if I look at this, this is a meter large and it's 210 in the air. So my half height is 88, which means my player is 166 centimeters tall. This is 1 meter tall or 100 centimeters tall. So, and this is 50 centimeters. So if I would just fit, it would be 166 plus 50. So if I make this 12.7, is that 217, then I should be able to just walk under it. It should just be at that level where I can just walk under it. Yeah, without crouching. Okay. And then if I make it 215, I should be just at the point where I'm hitting it. Burp. Yeah. So I want to make sure my check actually catches it in edge conditions, and it does. So it's working perfectly. And I'm not going up into that geometry. You always want to check your edge conditions. I could even nudge it up by 1 because it was 217, so 216. I should not be able to go under it, or I should. I can't remember. I can't. So when I go under, does it actually trigger? Nope. And it goes up. Yeah, I thought I was going to have to add 1 to it, but I don't. So it works right on the edge condition. And then I go up 1 more centimeter and I can just walk under it. So everything's working. My debug's removed. And we've got essentially our crouching working like we did in the blueprint in C++. That's it. All right. Have a great day, guys.